Welcome to Study Loop.
Okay, this is question 28.58, where we have an electron that's moving directly towards a long straight wire that has a current. And we're not told what direction the current is, but I'm just going to say that the current is moving to the right here. And the current has a magnitude of 8.6 amps. So we know that at this point, when the electron is 4.5 centimeters from the wire, it's traveling straight towards the wire at a velocity of 6 times 10 to the 4th meters per second. And we're asked about the magnitude and direction of the force that the magnetic field exerts on the electron. So the first step that we have to do is find the magnetic field generated from this current here. So the magnetic field from an infinite current of wire, I've written up here. It's going to be proportional to the current magnitude and then the direction from the wire. So here we are told that this is going to be a distance d, and that d is going to equal 4.5 centimeters. So we have our b now. We can just plug in everything that we have, 8.6, 4.5 centimeters. And now we need to calculate the force. So the force is going to be Q, the charge of the particle, which we know is going to be the charge of an electron, which is going to be 1.6 times 10 to the minus 19 coulombs. The velocity, we're told here, is 6 times 10 to the 4th. The magnetic field we just found up here. And now the sign of phi is the angle between the velocity and the magnetic field. So first, let's think about the direction that the magnetic field is going to be going in. So if the magnetic field is caused by this current, using the right-hand rule, if we point our thumb in the direction of the current to the right, that means that at this point, our fingers are going to curl out of the page directly at this point up here. So that means that the direction of the magnetic field caused by this wire is out of the page. And that means it's completely perpendicular to the velocity here. So the angle between the magnetic field and the velocity, which is pointing straight down, is going to be 90 degrees. So this sign here is going to be the sign of 90 degrees, which is actually just equal to 1. So we can just ignore that term for now. So now all we have to do to calculate the force is just plug in all the numbers that we have. So since we're just concerned about the magnitude right now, I'm going to ignore the sign, positive or negative. We'll think about that in a second. The magnitude of the charge is this. The velocity is going to be this. We have our magnetic field here. We can plug in I is 8.6. And then remember, we have to convert everything to SI units. So this is 4.5 centimeters, this distance, but converting that to meters is going to be 0.045 meters. So plugging this in, we should get a result that is 3.67 times 10 to the minus 19 newtons, because this is a force. So now we need to think about the direction. This is the magnitude. Again, we had the magnetic field pointing out of the page. So in this, when we calculate the force, we need to take a cross product between V and B. So we're going to take the vector pointing down is the velocity. We're doing that cross B, which is pointing out of the page. So when we use the right-hand rule, what that gives us is a result that points to the left. But remember that the electron has a negative charge, which is going to flip the direction. So when we take the negative of that, that means that the direction of the force is actually going to be pointing to the right. And that means it's the same direction as the current. So I'm not going to actually do this out, but if you had picked that the current was actually going in the other direction to the left, then you would find that the force points to the left. So what we can say here, we don't know whether the current is going to the right or the left, but we can say that the force is going to point in the same direction as the current.